Wisconsin. There actually are too many people in Wisconsin that I don't want to talk to everybody in Wisconsin, so we would take a sample. So what's my sample going to be maybe for this? Would you guys be a sample of that? Yes, you would be a sample. Would you guys be a good sample? Why not? Actually, there's plenty enough people. Believe me or not. I don't care if you believe me because it's true. How many is it? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It's almost enough. Yeah, you're right. We want roughly around somewhere above 30 normally.
So, because we're not from Wisconsin?
Oh, let's go back to this. I'm sorry. The Wisconsin thing was just another example to make sure you understand population, right? So that example is now gone. We're going to let them go eat potatoes. The sample for this, you guys are a sample, but again, why are you not a good sample?
Gotcha. It's because we're all...
Say again? All right, so let's get past that. Let's say we had a few more people in here, but to be honest, this is still a decent... the size wouldn't be as big of a problem as some other problems.
It would be a good sample if we were doing study for college students, right?
Well, we are. Grossmont students, that's our population. So you all are Grossmont students. But remember, you're trying to say something about all Grossmont students. So the people you actually talk to should be how related to everybody. I mean, why are you guys not a good sample for this?
Because there's not enough diversity. We all are in class at the same exact time.
Beautiful. This is a 9 o'clock class. It's a math class. It's an experimental math class, right? You all are here for could be similar reasons. So diversity is a perfect example, and diversity not just racially diverse, but I'm talking about age-wise, time of day, type of class. Does everybody have to take this class? No. Does everybody come here this early? No. And so forth. You guys kind of with me? So really what we're getting at is, to be fair, you guys would not be a fair sample. If I analyzed you guys and I asked each of you, did you drive to school today or did you ride the bus or something? I could get results, but would it be results I could actually trust? No, because you guys might bias the data some direction or another. You guys understand that? There could be something about why you're here that would bias my results. So what would be a better way to get a sample then of my population? What's a better way to get a sample?
Randomly?
Yes, but that's way too vague of a word. How would you do it? I like it. We're getting closer now. Oh, I see. You don't want to make any assumptions beforehand. You want, because, I don't know. I'm not that good. I'm like, you look like you could be on a bus. I'm not sure what that means. If they're all like, oh, I'm like, man, you look like you came off a bus. I did. Yes. Say again? Okay. So there's two ways to do it. You could talk to people, and you got one thing going so far, which is, I think you said different times a day? All right. Right? Or the other way to do it is not even to talk to anybody. Just get access to the records, which they probably wouldn't give us, right? But I like that. If you have access, you could do it all through the computer. You can have the computer randomly pick people or make a list of names and have numbers, and then you just randomly pick them out of a hat or something. You guys with me? But if we were going to go talk to people, because we probably don't have access, right? If we wanted to... The clock is still up there. There's too many if I want, but I'm not going to talk to everybody. I'm going to take a sample.
You can count the cars on the average, and then there's like, I could go out at 2 o'clock and count how many cars in the park.
Oh, I see. But that won't help me with, I don't know how many people were in each car. I got to talk to people. You know what I mean? I got to talk to people. So how would I pick the people to talk to? I would take different times a day. What would I physically go do? Maybe. Survey, sure.
Maybe age groups.
Okay, I like it. Okay, let's getting into a little deeper than, but you could actually take like a percentage of younger people, a percentage of in the middle, a percentage of older people. You could actually go that far, but let's not go that far.
Could you just ask like every fifth person that walks by?
All right, that's beautiful. That's what's called systematic sampling. So every fifth person that walks by. Now, what's wrong with some of those people if you're just walking by? Is everybody walking on the campus at certain times of day actually a student here?
No.
Some of them are administrators, some of them are faculty, some of them are just walking because they want to walk, right? I live over there, I just felt like walking. Okay, all right. Yeah.
Did you like classrooms take like the science center?
I like it. So, different times of day, different classrooms around campus, different classes. All right, cool. You see how we're controlling for what's wrong with you guys. You're not bad people. But you would be a bad sample for this, right? Because what I want, here's the thing. Here's what I want from a sample. So the sample could be, let's be specific. Let's say 80 students, different times a day, different classrooms. That's pretty good. You're getting closer to the ideal. And the ideal is to have a representative sample.
Oh, because I work with the surveyors for the airport thing. And
Oh, cool.
We would do, like, we would target gates, like 5 in the morning, we would get southwest gates. And then at 2 in the afternoon, we would go and do Yanaki.
Okay. And then survey people.
From here, 80 from there, 100 from here.
Sweet.
Just for all of the airport and get different people.
I like it. That kicks ass. So guys, that would be like, you sort of sound like you're doing something called cluster sampling, which is where you break an airport into areas, and then you survey from those areas. Actually, it's more like stratifying, but we're not going to get that deep into things. I'm using some words you're going to hear if you take stats. But there are all these different little ways to get to the best sample that you can do. You can break an area up into its zip codes and then take a certain percentage from each zip code, for example, and that would be a representative sample of that area, right? But the real ideal, to be a truly random sample, what has to happen is every element of the population, so it could be a person, it could be shoes, it could be dogs, I don't know. So every element in the population has to have an equal chance to get into the sample. That would make it fair. So what was wrong with you then in the terms of that? Not everybody has a chance to be in the sample. Because not everybody in Grossmont is in my class. Thank God. Holy shit, I can't imagine. I would definitely do online homework. There's no other way around. So truly random means every element in the population. You guys cool with me using that word element? Everything in the population has an equal chance to be in the sample. So very often, when they do polls, they'll call people. And what's wrong with that?
Not everyone answers.
All right, that's cool. Not everyone answers, but they have controls for that. Even more fundamentally, what's wrong with that?
They don't know the power.
Not everybody has a phone. Right? That's, that's like, hey, but it's also a phone. I like it. Okay. So there are problems with the way, but then you get as close to this as you possibly can. Because otherwise, I'm not going to believe what you find out. How are we doing so far? So you got a group of people you want to say something about. You have a group of people picked so that this is true that you're actually going to talk to. Because you ain't got time for all these 20,000 people. Right? Sorry, 20,000 people just don't got the time. I got to be careful about which words they actually use. And then, of course, once I've picked my group, what am I going to do with them? Experiments. No, what am I going to do with them? Remember what we were trying to say? I should have written up here. We were trying to say what percentage of Grossmont students drive to school, right? So once I get these 80 students, what will I do with them? Ask them something, right? And they are going to hopefully answer me. And so those answers, the data, would be the answers to the questions I ask. So the data here could look like, for example, the data here would be very simple. The data would be, what would the data be here? What would the question be? All right, it could be that, or even more fundamentally,
Yes or
do
no?
you drive to school?
Yes or no?
And the data would be yes, yes, no, 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 yes, 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 no, 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 no. What? Repeat the question. No, answer. You guys kind of with me here? I mean, this is true always. There's a group of people you want to say something about, but they're way too big. I can't get to everybody. So I take a sample trying to make this true. And then I ask them questions and get the data as the answers. And then I can take an average or a percentage. Now with yes, no data, I can take a percentage that said yes, and that would answer my question, right? Sweet. All right, so that's the words that we use to describe the process of getting to the point where I can say something. I can give a conclusion. It looks like 78% of gross month students drive to work, drive to school, right? And of course, in my brain, it's work. But if I said 78% of gross month students drive to school, why is that kind of misleading in a way? Based on what we just did. Where did I get that number?
The sample size.
From the sample. But the way I said it makes it sound like I'm talking about
All the students.
all the students, right? So that's why at the bottom of the screen, you'll always see, if you ever see like 44% are going to vote for this guy or whatever, at the bottom of the screen you see this, plus or minus 4%. You ever seen that? And if you take statistics, you'll actually learn the equation behind this number. This is kind of like my error. This is how much I think I'm off by. You guys, yeah, the margin of error, I love it, exactly. And there are equations that govern this number. And the larger my sample is, what do you think is going to happen to this number? The bigger my sample is, this number is going to get smaller. I'm going to be more sure about what I see if I take a larger sample. Does that make sense? Somewhat. Okay, so but we're not going to get that deep into it. We're not going to look at all the equations because they get a little gross. If you take statistics, you will. And gross is beautiful. Hello. Gross equation is beautiful. Let me see. What else do I want to do? Blah, blah, blah. Blah, blah, blah. I want to make sure I get all the little words they use. Oh, by the way, this here is an example of inferential statistics. What's that root word mean? Infer. What's it mean to infer something? Assume, based on what you see, right? So the reason it's called inferential is because this came from a sample, but I'm going to infer that about the same rate applies to the whole population. And the more I was closer to this, the more correct I probably am. Okay, maybe correct. Okay. So, a couple last things, and then I'll let us out of here a little early. Right, just to keep tradition going. So doing this analysis is not going to be a big part. Is not going to be a part of this class much. We will do stuff like calculating averages and stuff. We will talk about some of the weirder stuff, but we're not going to do the full-blown equations. We're just going to talk about the meaning behind them. So when you get to statistics, you've heard of it, and then your only problem then is just learning the equation and why it works. You already kind of know what it means. We don't really focus on inferential. We focus on what's called descriptive statistics. And this would be something like if we did this data. I'm sure you guys have all seen this kind of thing before, right?
Pie chart?
Yeah, pie chart. So this would be one example of descriptive statistics. It doesn't make an inference about anything. It just shows you what you see in your sample. This is what we saw in our sample, for example, right? So it doesn't make an inference. It doesn't include this kind of stuff for the big calculations to cover your ass for what you don't know. It just says this is what we saw. Another example would be like a bar graph. So if I made a bar graph of ages in one of my classes, more than likely it would look something like this here. Yeah, and there might be some, up here with me. Right? I mean, this is basically, I did this in my stats class, and it was even taller than normal here, which was neat. So I had a lot of people right out of high school. What the hell does this mean? Holy shit. I mean, let's give us some numbers here. Percent. So what percentage of the people in this class are 18? Or this imaginary class here? 20%. 11. So this is actually called a histogram. We will talk about how to create a histogram. The difference between this and a bar graph is what kind of this data here, the ages, they're like truly numerical. You can say how far apart they are, so forth. A bar graph would be with data that's not numerical. Like if I go back to so here's a bar graph. On the blah, 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 right? You guys with me? This is non-numerical data. What's Honda minus BMW? I don't know. Pinto? You with me? So it shows the same idea. What percentage is each of these? But it's categorical data. It's name data. This is numerical data. I call that a histogram. There's no gaps here. There's got to be gaps here because it's not really a true scale on the bottom. There's just names. Okay, man. Let me let all that sink in. I know you know how to read bar graphs. You've seen them somewhere in your life, besides there. Right? Okay, let me see. How much more do I want to do? You're like, no more, Chef. You're done. You're done. Stop. So, I mean, just to give you a little preview, what we're going to be doing next is doing the work necessary to construct this. What work do you think I had to do if I actually made this? This is ages in my 160 class, let's say. What work did I have to do to construct this?
Data.
I like it. What's my data going to be?
Everybody's age.
Everybody's age. So I actually went around, because not everybody filled out my survey in the class, those people. So I went around and said, anybody feel uncomfortable telling me their age? Nobody said yes. And so I said, what's your age? How old are you? How old are you? And I just wrote it down. What did I do next, once I got all the data?
Put it into a
Damn, that's right. I just skipped every step, just went straight for it. So I obviously had to do what? I had to figure out.
Analyze the data.
Okay, in what way? How did you get 5% were 17? I had to figure out how many were 17 divided by
The
total number of people. All right, I love it. So you can see the work that goes into this. One other thing I do want to say before I let you out here. There is actually something called a stem and leaf plot. Does it sound familiar? It sounds familiar to one person.
Yeah.
Let me give you an example of one. All right, that's plenty. All right. So this will be the last thing we do, okay? All right. Everybody wakes up a little bit. I like that. Okay. The reason it's called stem and leaf is I can collect this and put it in order if I look at it as the 30s, the 40s, the 50s, 60s. So 30s, 40s, 50s. These are my stems. My stems. My stems. And my leaves are going to be what comes off of those stems. So like for the 30s, what's the lowest 30? 32. I put a 2 there. 36. Put a 6 there.
7.
37, 38, 39. I like it. And then you do the same. 40 has only got 41, this poor little thing. And then 50s, 2,
4, 7,
2, 4, 7, 8. And then 60s is just 60. That's a stem and leaf. Oh, that's so hard, Jeff. Now, to be honest, if my data would have looked like 4.1, 5.2, 3.9, this would have looked exactly the same. It's just that I have to give people I have to give people a key. So I have to say key. 32 means 32. Oh, I went back to what it was. Sorry. So if it was 3.9, 5.2, 4.1, I'd say 32 means 3.2. Then people know how to read all of these. And look, doesn't it make sort of like a bar graph, like a histogram thing? I mean, you can see this tall here, so that's the most people were in their 30s if this is ages. And then the second most are here. So it's a very quick way to sort your data, and it gives a rough kind of bar graphy look to it. Okay. All right, I think that's plenty. Don't forget tomorrow, let me say, I said yesterday we're going to have a quiz tomorrow. Here's what it's going to be. It's 1.4, 1.6, 1.7. Those are the ones that weren't on that first quiz. 1.4, 1.6, 1.7. Remember, 1.4 is the radical stuff. Oh shit. Yes, ma'am?
Can we write down the formulas? We have them already.
Oh, I'll put them on the sheet. Yeah, I'll put them on the quiz. The formulas for the sequences stuff. Yeah.